Welcome back. In this video lecture, we will be looking at the force measuring techniques. Okay, some of these techniques are labeled under direct and indirect methods. Okay, so far we have looked at the various types of forces, right? Van der Waals forces of attraction, electrical double layer interaction, right? But we have used some fundamental equations, and then we try to derive the develop the equation for interaction between to obtain pairwise interaction between planar surface or or between two particles, right? But in this video we will look at some of the measurements that we can perform to assess the forces, right? To understand the interaction uh, you know between the surfaces, or to determine the forces directly or indirectly, right? That is exactly what we are going to look at in this video. Let's begin. Yes, so why first let us ask a question, why we need to measure forces? Because only then you will be able to say whether a given dispersion is a stable dispersion, given system is a stable system or not. For example, if you want dispersion to be stable, you want to promote electrical double layer interaction between the particles, right? Especially when you deal with the liquid solid phenomena, so that you will be able to prevent the aggregation, right? So for that, one has to understand the type of forces involved in the systems, and if you want to understand or study the interaction in colloidal systems, one has to understand address the forces involved, right? So for that we need to study various direct and indirect methods to understand the types of forces involved. The significance part, if you look at, it is very crucial in studying the adhesion phenomena, wetting and emulsion stability and nanoparticle interactions, right? So in these cases you need to understand the forces, various types of forces involved, and for that we need to determine the forces, right? There are different the methods can be classified into two. One is the direct method. So this uses some sort of a probe. It is in situ method. So it uses some sort of probe to measure the the forces between the surface as a function of several factors. One of the factors could be the distance between the probe and the surfaces. Okay, the other one will be indirect method. So you will have several methods labeled under this category. So you will be measuring some property, okay, some macroscopy property, right, uh, to deduce information about the microscopy property, like intermolecular interaction forces or colloidal interaction forces, right? So that is nothing but indirect methods. Okay, that is exactly what we are going to look at under indirect methods. So let's start with the indirect force methods. The first set of methods that we will look at is the adhesion force and peeling force. Okay, remember we have looked at the adhesion force, work of adhesion and work of cohesion during the module 2, where we shown that by computing the surface energy of block A and surface energy of block B and subtracting them with the interfacial energy of block A and B, you will be able to compute the work of adhesion. which is expressed in the form of energy per unit area, joule per meter square. Okay. So we have looked at this during the module 2. Now, exactly what we are doing is, by knowing the force required to detach them, by force required to detach the particle, I mean these two surfaces, okay, away from each other, by computing the that particular force, one can actually calculate what will be the adhesion force, right? And then one can get more insight into type of forces, whether it is due to hydrogen bonding, ionic bonding, and van der Waals interaction. So those aspects can be studied later. Okay. And what governs this force is basically the surface chemistry between the surface, roughness, and electrostatic interactions at the boundary between two surfaces, right? So in the case of peeling force, you will be computing or deducing the force, adhesion force or peeling force, by calculating the amount of force required to detach an adhered material via peeling. So, the governing factor here will be the certainly peeling angle, right? So that will actually affect the peeling force, right? And material properties, right? And adhesion strength, right? So these are governing factors when it comes to peeling force. And these are some applications where you will encounter the you will use these adhesion force quite often. That is the nanoparticle adhesion coatings, right? Whenever you deal with coatings, you want to know what is the adhesion strength of the coating material over the surface, and biomedical interfaces. So these are some applications you will uh, often deal with when it comes to adhesion force. So some situations where the peeling force will be required to calculate is the adhesive tapes. When you design adhesive tape, right, for certain application, you will have to calculate this peeling force. And protective films, when you want to develop the protective film, okay, to prevent the surfaces from rusting, so for those aspects, and wound dressings. So here also you will be required to calculate what is the peeling force, right? So these are some applications when it comes to peeling force. Next, so these are again indirect methods. Okay, by calculating these forces, you will be understanding or assessing the type of forces involved between the surfaces, right, or liquid between the uh, surfaces, especially when you deal with the adhesion force as well as the peeling force. Okay. Uh, Next comes the the contact angle. Okay. Again, based on the Young-Dupre equation, this one you will be familiar because we have developed this equation during our module 2. So by knowing the theta of the liquid, okay, contact angle established by the liquid with the surface, you can calculate the adhesion strength or adhesion force, I mean adhesion energy in this case. Okay. For that, you need to know what is the gamma Lg component of the liquid that you will be dealing with. Okay. And this is very easy to obtain, right? Whereas the theta one has to determine, okay, using Sessel-Drop method. Okay. So that you will know theta as well as gamma Lg. By knowing these two component, you can calculate the adhesion energy, right? In this case, work of adhesion, right? Yeah. So this particular aspect, this contact angle will help you determine the adhesion force, not only adhesion force, Sometime if you know the work of adhesion, you can even calculate the surface tension and the interfacial energy, right. So challenges involved in this approach is this method cannot be applied if the surface is rough and it is heterogeneous, because it affects the accuracy. And also you will be discouraged to use this method if uh, the surface is exposed to contaminants and humidity, because these factors also certainly affect the result. And when it comes to application, you will be able to use this method to uh, address the wettability, okay, of when it comes to colloidal stability, okay, and bioadhesion. So when you want to calculate protein adsorption, cell adhesion and biocompatibility, this approach will be certainly useful. Again, in emulsions and foams, where wettability determines the droplet stability. And last but not least will be the microfluidic and lab on a chip device. The surface wetting is very crucial factor in this application. So one has to know what is the wetting, right, behavior of liquid spread on a surface. So if you want to understand the adhesion between the film thickness, the resistive film and the surface, you need to know the wetting behavior. So here it is certainly going to be very useful, right. So this is again indirect method, okay. Soap and liquid film. So here what we will be doing is we will be using several spectroscopic technique, okay, to determine the film thickness, okay. It could be due to soap film or it could be liquid film, right, confined between surfaces, right, two surfaces, whereas it could be due to soap film formed by some surfactant, right, in water. So if you want to understand this, so if you want to understand the force of interaction between the soap film and the surface, or liquid film and the surface, you can perform several of these techniques to understand you know uh, what kind of forces involved, right. So this interferometry, if you use interferometry, so basically you will be assessing, right, finally you will be able to assess or calculate the capillary pressure, disjoining pressure, adhesion force, and finally you will be able to assess molecular interactions, right. So for that, what we need to do first is we need to understand the film thickness, okay. Once you know that, you can plug in these values in this respective equation, and you can calculate the capillary pressure or disjoining pressure, van der Waals and van der Waals forces of attraction or electrical double layer interaction by knowing the film thickness, okay. So how we are measuring the film thickness is what important. Each method offers different strategy through which one can use the film thickness, I mean measure the film thickness. um, eh, but uh, but each method has limitations, as in it is these methods are applicable only in this measurement range. So depending on the measurement range, one has to pick up the suitable method. So in the case of interferometry, based on white light or monochromatic light, so basically what you will be doing is you will be performing the thin film, sorry, you will be measuring the uh, film thickness by generating the interference pattern, right. So based on this interference pattern, based on whether you use white light or monochromatic light, you will be able to determine the film thickness. Once you know the film thickness, you can correlate that to find out the capillary pressure or the disjoining pressure, okay. And later you can assess the type of forces involved. You can infer about van der Waals forces or the electrical double layer interaction and all that, right? Right. That is all about the interferometry. Okay. This is applicable in the range between 1 nanometer to 10 micron meter. In the case of ellipsometry, what we basically do is we measure the change in the polarized light, okay, um, of reflected light. Okay. So, basically it records the amplitude change and the phase change of the polarized light. Okay. Based on which you can get several information like film thickness and the refractive index and surface interaction. So, based on which you will be able to address or determine film thickness, refractive index and surface interaction. So, by knowing this information you can relate this to infer the type of forces that you want to compute. Okay. Then comes the X-ray reflectivity. Okay. So X-ray reflectivity, the reflected X-ray intensity obeys the Fresnel law. Okay. So, Fresnel law basically tells about, it describes how light can reflect or transmit when it passes through an interface, okay, with two optical media, right. Okay, especially when light passes through liquid solid or liquid gas interface system. Okay, when it passes through one bulk phase to another bulk phase, it encounters different optical properties, right. So, because of which it generates different interference pattern. By using such interference pattern, one can deduce the information about thickness of film, electron density, right, and interface roughness and layering of molecules in confined films, right, based on which you can measure uh, you know uh, capillary pressure or disjoining pressure, and you can talk about whether the type of force involved or van der Waals force or electrical double layer interactions. By deducing this information, you can comment on whether the forces of interactions are due to van der Waals or electrical double layer. Okay. So, that is how the uh, measurements, force measurements are done indirectly through these spectroscopic techniques. Okay. Yeah. So, here comes the direct force methods. Okay. Nothing but surface force apparatus. Okay. We have looked at indirect methods, right, and now we will look at the some of the direct force methods. Yeah. So, even before this, I think I forgot to mention about the additional technique under the indirect method. So, that is nothing but coagulation study. Okay. So, by performing the coagulation study, one can even assess the van der Waals forces of attraction. Okay. So, this method of assessing the van der Waals forces of attraction is very simple. So, how one can do is, let us say you systematically conduct the coagulation study by adding the salt at the regular interval. Okay. So, by knowing the critical concentration at which the surfaces or the colloidal particles tend to aggregate, uh, by determining the critical salt concentration, we can actually compute what is known as the electrostatic force. How we can do is, let us say we know that the coagulation occur when these particles or surfaces tend to overcome the electrostatic repulsive force between them. Okay. So, by knowing this concept, what we can do is, since we identified the critical salt concentration, at that particular concentration one can measure the zeta potential value, and the other parameter called d by Huckel parameter k. So by measuring these two parameters at the critical salt concentration, we can substitute these values back into the equation that we derived in the previous lecture, that is nothing but electrostatic force due to electrical double layer interaction. There, if you plug in these values, what we will get is the electrostatic repulsive force itself. Okay. Since we know the electrostatic repulsive force, and we also know that coagulation occur when the surfaces overcome the electrostatic repulsive force, right. So we know that at this particular critical salt concentration, these particles or surfaces tend to coagulate, which means that they have overcome the electrostatic repulsive force. Okay. So by computing the electrostatic repulsive force, indirectly we can calculate or compute the van der Waals forces of attraction. Okay. So in this way also you can indirectly assess the van der Waals forces of attraction, right. So one has to systematically conduct this coagulation study, to understand the strength of the van der Waals forces of attraction between the surfaces or the colloidal particles. Okay. Next we will move on to the direct force methods. There are a couple of methods. So one, I mean the one of them, so the first and foremost technique that we can see is the surface force apparatus. Okay, SFA is often denoted as SFA. Okay, so this actually measure normal and shear forces, right, normal and shear forces. Okay, as a result of the interaction between two surfaces. Okay, right, at nanometer resolution, usually in the range between 0.1 to 10 nanometer, a few tens of nanometer distance. Okay, separation distance. So by measuring these forces, one can actually obtain the information between force and distance, that is separation distance. The principle of operation is very simple. So one has to take the mica surfaces, right. Why mica is preferred? Because when the surface is cleaved, basically it becomes very flat, and the smoothness is comparable to the atomic scale. That's why people often prefer these mica surfaces. When you bring these mica surfaces together, right, which means that one of the surfaces will be rigid, the other one will be moving. The moving surface will be attached with the spring system. So when these surfaces brought together in a very close proximity, that is at a separation distance of, let's say, few nanometer distance, there will be molecular forces or atomic forces that will cause the deflection in the spring system. By determining this deflection, one can calculate the information about the force. Okay. The separation distance can be measured using the multi interferometric technique. By using the white light interferometric technique, one can measure the separation distance. By knowing the separation distance and the force, it is easy for us to calculate to understand the type of forces involved and also the magnitude of the forces, right. Okay. uh, so important point to be noted is the piezoelectric actuator is often used to systematically vary the separation distance, right, between the surfaces. Okay, right. So some of the key features of this technique is you can measure the force in the range between uh, at least micronewton range to nanonewton range, right. The force versus distance information is very useful for colloidal interaction, for understanding the colloidal interactions. Okay, and to assess the strength of adhesion in lubrication, and to understand more about the molecular forces. Okay. Next comes in this category, next comes the AFM, which is nothing but high resolution technique. Okay. So what it does is it measures the surface topography and mechanical property by detecting the forces between a sharp tip and a sample. So basically we like previous one, we we detect, we I mean capture the force between the we obtain the information about the forces between a sharp tip and a sample. Okay, right. So here, like SFA, here sharp tip is mounted on a flexible cantilever, because when sharp tip and the sample interacts at a very close distance, close distance, uh, with a separation distance of, let's say, few nanometer in distance, the atomic forces or the molecular forces, okay, will cause the cantilever to deflect. Okay, right, as a result of interaction between the surfaces, these forces will cause the will make the cantilever to deflect. Okay, by determining this deflection, one can again collect the information about the force versus the separation distance. Okay, some of the key features of this technique is you can measure forces in the range between nanonewton to micronewton. Okay, like your SFA, right? Like yeah, what we have seen in the similar range can be also obtained using the SFA. So this technique can be operated in three different modes: contact mode, tapping mode, and non-contact modes. Remember, we have looked at the techniques, few characterization techniques. We have given enough insight into some of these characterization techniques in module 1 itself. If you can go back and refer to lecture number 3, you will be able to, you will be able to get more insight into these techniques, right? Okay. So we will stop here, and we will continue from the next lecture. Thank you.